ID, the Future, a podcast about evolution and intelligent design.
Well, welcome to ID the Future. I'm your host, Andrew McDiarmid. Today I'm welcoming back medical illustrator and artist Jody Sjogren to discuss her career as a medical illustrator, the insights she has gained about the similarities between organisms and machines, and how artists can give us a glimpse into the mind of an intelligent designer. Jody graduated from Colorado State University with a Bachelor of Science degree in zoology, and then from the Medical College of Georgia with a Master of Science degree in medical illustration. For 43 years, she ran her own business, Metamorphosis Studios, doing medical illustration, graphic design, aviation art, calligraphy, and floral oil painting. Though much of her artwork has been produced for the medical field, she has also enjoyed connecting biological avian flight with human-designed flight machines. Jody, welcome back to ID the Future.
Thank you, Andrew. Happy to be here.
Well, in a separate episode, you shared some of your remembrances of our longtime colleague, Dr. Jonathan Wells, who passed away in 2024 at 82 years old. You also discussed the experience of illustrating Dr. Wells' classic book, Icons of Evolution. So I encourage listeners to go back and listen to that. That was a great episode. Today, I'd like to focus on your career as an illustrator and talk about some of the parallels between the visual arts and the process of design evidenced in the natural world. Let's start with a little bit of your background. What got you into art and illustration, and where did you get your training?
Well, as you mentioned in your introduction, I went to Colorado State University for a degree in zoology and almost a minor in art for my undergraduate training, and then to the Medical College of Georgia, where I got a Master of Science in medical illustration. And those classes ran contiguous with a lot of the medical students' classes like human anatomy, neurology, embryology, pathology, stuff like that. And then in addition to that, we did a lot of surgical observation and drawing and kind of went on our own track as far as developing our illustration skills.
Now, you've run your own business for over 4 decades. What sorts of things did you illustrate throughout your career?
Well, most of my work for the first 2 decades was in medical art, which involved a lot of surgical observation and drawing, providing illustrations for journal articles and books of a medical nature, creating large panels with medical illustrations for legal cases like personal injury, workers' compensation, medical malpractice. Did some exhibit design and illustration for medical meetings, things like that. It was highly technical work with a need for extreme accuracy of information, as well as a creative approach and artistic skill in putting together the illustrations. It's like you have to get it right as far as the information is concerned, but you're always trying to make a good piece of art, too.
Reflecting reality, but doing so in a creative way.
Yes.
Now, as an offshoot of your interest in aviation, you also started an aviation art print business in 1983, which allowed you access to military bases and interesting aircraft. It also opened doors to clients like the US Air Force, NASA, and a lot of general aviation contractors. And between studying and illustrating both human anatomy and machines, you started noticing what you eventually termed the machine living system analogy. Tell us a bit about that.
Well, from the standpoint of the intelligent design evolution debate, these two artistic disciplines, the medical illustration, which was very biologically involved, and the aviation art, which involved drawing machines, it led me to a way of thinking that I eventually termed the machine living system analogy, which is to say, having spent so much of my time studying and illustrating both human anatomy and machines, I began to see the analogies between systems in living systems and man-made machines, such as structural complexity, fuel delivery, electrical systems, sensory systems, power plants, etc., as evidence for design, not random material processes. Because having been trained in biology, I took evolution courses through my college career and had always been kind of taught this evolutionary framework for the origin of life. And yet here I am illustrating these complex machines which have so many analogies to living systems. And I'm thinking, why aren't we thinking in design terms here when it comes to living systems? It really just kind of a modern version of William Paley's watchmaker argument. But when you would put forth this kind of an argument to evolutionists, you would not get a legitimate rebuttal. They wouldn't actually deal with you on those terms. It was strange.
But you actually did see machines and living systems, and you saw the connections there, and the analogy was strong to you.
Exactly. If you look at a human body, for instance, its structure starts with a skeleton, and then ligaments, tendons, muscles are applied for movement, and then you need a cardiovascular system, a power plant, the heart, to deliver nutrients and oxygen to the muscles, and on this goes. It's the same thing with an aircraft. You have spars and longerons and a framework that um, develops the fuselage, the tail section, the wings, and everything. You've got a fuel delivery system. You've got electricals, mechanical systems, and all of that came about by design. All you have to do is talk to an aeronautical engineer and look at the blueprints. It's all right there. Just somehow or other, there needs to be a logical thinking when it comes to origins of complex structural entities like living systems and machines. We live with machines all the time, and we know they're designed. What's the problem with looking at something infinitely more complex, a living system,
Yeah,
and saying the same thing?
right. Yeah, I mean, even if you did it just as a fun experiment, you've got biologists who are trained on evolutionary theory as the origin for organismal form. But what if you just take a biologist who doesn't have that training yet, and you just go ahead and train them in the principles of engineering, as well as science and biology, and you leave out the evolutionary part? Well, how is that biologist going to function? How is that biologist going to study living things? It's just a completely different perspective, and we need more of that.
I agree.
Now, your husband is a structural systems engineer, and you said his job included the following process: thinking up a structure, making a blueprint, having it read by a fabricator, and then building the structure to specification. How did you see your husband's work correlating with your work as an illustrator?
Oh, in a wonderful way. Both of us have this ability called structural visualization, which is to say that in our minds, we're able to come up with a picture of something that we want to bring into reality. In his case, as a structural engineer, it had to do with power plants and conveyor belts and radial stackers and all those kind of machines and structures that deal with bulk materials that have to be handled, like coal and grain, cement, things like that. Well, he can draw a picture in his head, and then he can translate that to a drawing on a piece of paper, which becomes a blueprint, which is then um, sent to a fabricator, and the fabricator brings materials together to produce what he's drawn and then construct it. Of course, that's a simplification of the process, but it starts with a request for proposals. What do we need here? And the needs are outlined in that request for proposals, and then the engineer puts together drawings, blueprints, etc. That's how it goes. And it's sort of like, to design is to invent. If you want to bring something into existence, you have to use the design ability, the ability to conceive of something in your head, a picture of what needs to be brought into existence, and then show that to somebody else by means of a visual form, a picture, so that they know what's in your mind so they can fabricate it. Well, the process that I use in coming up with an illustration, when a client comes to me and says, for instance, um, our client, okay, so it's a legal firm. They come to me and they say, our client was injured in this railroad accident, and these were his injuries. Here are the x-rays, the operative report, what was done to put him back together, et cetera, et cetera. And I am able to visualize in my mind what has happened to him because I know structure and anatomy. And then I can read the operative report and understand what was done surgically to put him back together. And I can show that then to the jury by means of a set of illustrations that make visual something that I know in my head. And so this is the process of design that both my husband and I share the ability to do. When I was working on all my aviation art, he enjoyed that a lot more than the medical stuff. But he would walk into my studio and he would take a look at my drawing and he could tell whether or not I understood the structure of the forward fuselage of an SR-71, for instance. And he could actually look at engineering drawings and critique my work.
Hmm.
It was fun.
Yeah. And in that sense, both of you were fabricators. And I do love that word. I mentioned that I do study technology at Discovery Institute. And, the word fabricate is built right into the idea of technology, techne, art, and skill. The idea behind technology is literally weaving or fabricating, building, creating things. And so that's a powerful word. And here you both were in different jobs, but doing that same thing.
Yes. And in fact, along the way, I came across a very interesting book by an engineer. His name is Eugene Ferguson. It's called Engineering and the Mind's Eye. Engineering and the Mind's Eye. And he writes about the process. And this book was published in 1997. He writes about the process that an engineer goes through to bring an idea in his head into reality. And it's the exact process that I'm just describing, how you need the ability to envision an object, whether it's a chair, a pyramid, a rocket, or a cathedral, in your head and turn it around so you can view it from various viewpoints in your head so you know what this object needs to look like. So you can come up with a blueprint that shows a plan view, an elevation view, and all that. So the fabricator can understand three-dimensionally what you're trying to bring into existence.
Yeah.
It's a great book.
Yeah, I'll have to look that one up. It sounds very interesting. Well, you've summed up the design process this way. You need a mind to conceive an idea, a will to do it, and a means to make it happen. Sort of reminds me of the criminal science mantra of, means, motive, and opportunity. How do you think that process translates to our understanding of design in the natural world? Obviously, you've seen some parallels with organisms. Do you think this can give us a glimpse into the mind of the intelligent designer behind life in the universe?
Absolutely, because one of the features of living organisms is this appearance that it's exquisitely designed for some purpose. And just to take an example from the living world and the machine world, a peregrine falcon versus the F-16 Fighting Falcon, a military jet. The peregrine falcon is a raptor which it hunts its prey by flying up to altitude, partially folding its wings, nosing over, and going in a dive straight down up to 200 miles an hour, and then rapidly pulling up and with its talons grabbing or hitting the bird that it's using as its prey. And the interesting thing to me about this falcon is the air management, the airway system. This falcon has a system of baffles within its nostrils that, as it's in this dive, slows down the air intake so that it doesn't just, according to Bernoulli's principle, suck all the air out of its lungs as it's diving. What an Now, evolutionists would call that an adaptation. I would call it a design feature because without it, this bird can't do what it does.
Yeah.
And think about the bird. It's got variable geometry wings. It's got this air intake system to moderate airflow. It's got retractable gear. It's got onboard maintenance and repair capabilities. It serves as its own air-to-air missile with navigational and lock-on systems. It survives mid-air collisions. In fact, it uses them regularly to refuel itself. It lands on runways as short as a tree branch. And lo and behold, it reproduces and raises its young. I mean, this is an amazing creature. Contrast the F-16 Fighting Falcon, a fighter jet in the U.S. Inventory, and this jet flies at supersonic speeds. Well, the problem with supersonic air is that if it hits the compressor, bad things happen. And so you have to design the intake system of that jet such that it slows the air down if the jet is going supersonic. It slows the air down so that when it hits the compressor, it's going at a subsonic speed so that the jet can take in that air and process it. And so all of this is a process of design, not randomness at all. It comes back to engineering in the mind's eye. What do we want to do here? What does this airplane need to perform? And how does it need to perform it? And so these are just two analogous systems, the air intake systems of a bird and a fighter jet, that I think bear consideration in the discussion of origins. And we could go on and on with systems like this in various organisms versus man-made machines and see that, gee, there's design here. This isn't just random material processes. This isn't just natural selection by gene mutation, etc.
Yeah. Good examples.
Yeah. So I think those are the kind of things that we ought to be teaching. If we're going to teach evolution, we need to teach the problems with it. Because that bird, if it didn't have that particular capability, if it didn't have that feature, it would not be able to do what it did so that it could reproduce and keep going. This is all too
Right.
logical to me.
Yeah. And yet that feature we're supposed to believe, was chosen through random mutation by an unguided process. But we're studying we're studying evolution, I should say, and showing that mathematically natural selection acting on random mutations does not have either the time or the creative power to do what they credit it with. So a lot of difficulties there, but those are some great examples. Now, when you and I were chatting to prepare for this interview, I told you about a new book from Discovery Institute Press called Plato's Revenge: The New Science of the Immaterial Genome. In it, science writer David Klinghoffer tells the story of Dr. Richard Sternberg and the potentially revolutionary idea he's been working on for 2 decades. Recent findings reveal that genetic and even epigenetic sources alone cannot account for the rich dynamism of life, not even close. Some other informational source is required, a source beyond DNA that is immaterial, so not bound up in the physical entities that we already know about in the cell. And this dovetails nicely with another new book by neurosurgeon Dr. Michael Agnor called The Immortal Mind, making the scientific case for the existence of the human soul and the immortality of the mind. Now, my question for you is this: have you been tracking the arguments for intelligent design in the last 20 years, and does it excite you to learn of these new aspects of the case for design in life?
Yes. And, a lot of us were having these kinds of thoughts in this particular direction 20, 25 years ago. But to see scientists really starting to lock onto this now and to write about it in coherent scientific ways is very exciting. I mean, the $64,000 question has always been, where did the coded instructions in DNA come from? Because when we're looking at this molecule that has the capacity to direct protein synthesis by the four-letter alphabet, basically on that sugar phosphate backbone, it's more than just the molecules themselves. What is the meaning of the order of those molecules? What is making it all happen? And to see that scientists are really diving into this now, I think is hitting upon the real essence of the debate. What
Yeah,
what
absolutely.
is going on in the non-material realm that is making something happen in the material realm? That is the
Yeah,
question.
yeah,
Very exciting.
it sure is. Well, in part one of our conversation together, you described the experience of illustrating Dr. Jonathan Wells' 2000 book, Icons of Evolution. And I encourage everyone to find and enjoy that episode. We'll just briefly touch on it here as we wrap this up. You created 26 pen and ink illustrations and 2 color illustrations for the cover, and you only had about 5 months to complete the project. What was it like bringing to life these icons, and what did it teach you about how artistic license can be used to promote narratives around scientific theories?
Well, it's like they always say, a picture's worth 1,000 words.
Yeah,
And for all these years, these pictures, these icons have been used to promote a particular narrative about the origin of life and its diversity. And I would say it was the greatest privilege of my career in medical and biological illustration to replace this false narrative with the truth.
yep. And if you want to hear the full story of that, listeners, please go back and listen to part one of our chat. Now, I have a teaching background and I regularly teach our textbook, Discovering Intelligent Design, to groups of students in homeschool co-ops. I think that's how I first came across your illustration correcting Haeckel's embryo drawings, actually. Now, besides Icons of Evolution, what other projects have you worked on with the Discovery Institute?
Well, some of my illustrations appear in their book, The Design of Life, which they collaborated with the Foundation for Thought and Ethics on. And then, of course, the book Explore Evolution and various things that Casey Luskin has written a number of articles that have been online that some of my illustrations have appeared in.
Yeah, they've had a long shelf life, haven't they?
Yeah, that's it, a long shelf life.
Well, Jody, how can those who are listening today find some of your artwork? I know you sent me some of the artwork that you did connecting, birds with different aviation machines. But is there a way? Have you done greeting cards or posters or a website gallery? Is there a way for listeners to see some of your work?
Well, probably the best way would be to go to the website www.daretomove.com and then go to the Aviation Art by Artist drop-down and just click on my name, and all the artwork, the aviation artwork that I have in limited edition print will come up on that website.
Okay.
daretomove.com.
All right. And of course, we'll share a couple of your pictures to go with these episodes, including the famous metamorphosis of ape to man that made it onto the cover of Icons of Evolution. We'll include that as well. Well, Jody, it's been a pleasure talking with you today. I really appreciate your time.
Thank you very much, Andrew. My pleasure.
Listeners, if you enjoyed today's episode, please consider sharing it with a friend. You can also help us by leaving a positive review and rating on either Apple Podcasts or Spotify. That helps us connect with others who may be interested in the evidence for intelligent design and the debate over evolution. I really appreciate your help. Well, for ID the Future, I'm Andrew McDiarmid. Thanks for joining us.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.